So before I start, are the slides visible?
Yes, sir.
The copy and SPSS. These are the three things. Are they all visible? Now, when I'm clicking, can you see it? Good evening, everybody. Today, the topic of our discussion is testing of hypothesis. I presume we are mostly from the background of social science, and we will try to limit our discussions to as much little as possible to statistical jargons. Rather, we will see hands-on how in different situations we can apply SPSS and do the necessary testing. Before we move to the practical part, we will just have a brief discussion about testing of hypothesis. Now, what basically is hypothesis? Hypothesis basically it's an idea that can be tested based on the available evidence. Say we say that the average weight of this class is 60 kg. So this is an idea, or this is the concept, or this is a statement, whatever you call it, that needs to be tested and it needs to be proven to be credible. So I am just making a statement. The average weight of this class is 58 kg. So this is basically a hypothesis. That hypothesis needs to be tested to be proven true. Now, for any investigation, the starting point is development of the hypothesis and then to prove through proper method that the hypothesis is correct, whether our hypothesis is correct or not, that we will see. For example, we say that 8 hours of sleep can keep a people healthy. So there is a statement. Now, whether it is correct or not, that needs to be tested. So the hypothesis needs to be tested. Now, in statistics, we will find a hypothesis is an assumption about the population parameter. So what is basically a parameter? A parameter is the characteristics of the population. Basically, it's a number that describes something about the entire group of the population. The weight of this class is 60 kg. So here the statistics here is 60 kg. So it is a number which describes something about the entire population. So this is what is hypothesis. So it is an idea, it's a statement that needs to be tested. Now, for testing hypothesis, what generally is done? So as we have already said that it is an assumption about the population parameter which is to be tested. So first what we do, we collect the data. Then we calculate the statistic, that is the number which describes something about the population. That can be the mean, that can be the standard deviation. And then we use the information available to us and judge whether the hypothesized value of the population parameter is correct or not. So basically, it is something like this. Say a class of 100 students, that is say the population. From that, at random we select say 20 students and we calculate the mean weight of those 20 students. We find it to be 60 kg. So the entire class is the population. The selection from that population is the sample, And the statistic that we calculate is based on that sample. Here, in my example, it is the sample mean. And through testing, we will say, or we will try to find out whether that sample mean is correct for the entire population or not. So with that sample, that the average weight of this class is 60 kg, which we are commenting from the sample, whether it is correct or not for the entire class. That is what has to be done, or that is what needs to be checked. So we will collect the data from the entire set, that is from the population. That data that is collected, it is the sample. We will calculate the statistic of the sample, do necessary testing, and then comment whether that sample which we have collected from the, whether the statistic that we have computed from the sample is true for the population or not. That is what needs to be done here. This is already I have talked about the now, to test the validity of the assumed or hypothetical value of the population, we gather the sample data and determine the difference between the hypothesized value and the actual value of the sample. We will later on take example and see how this is done. So one thing we calculate, and there is a value, there is a hypothesized value. We judge whether our computation and the hypothesized value is same or not, whether there is significant difference or not. The smaller the difference, the greater is the chance that the hypothesized value of the is correct. And the larger the difference, there is a chance that the hypothesized value is not correct. So what needs to be done in hypothesis testing? The first step is to state the assumed hypothesis, that is a numerical value of the population parameter. The average weight of this class is 60 kg. So this is the first thing. We develop an hypothesis and we give a value to it. The assumption that we will test, or that we want to test, that is known as the null hypothesis, which is represented by H0. So H0 here for us, here, if we, in my example, if I say H0 is average weight is 60 kg. Against the null hypothesis, there will be a alternative hypothesis. We will begin with the assumption that the null hypothesis is true. Until and unless we find something contrary to it, we will stick to this assumption. And if we find something contrary to it, then we will reject the null hypothesis and we will accept against the null hypothesis. There is another hypothesis, which is the alternative hypothesis denoted by H1. So our assumption here is the average weight of this semester students, it is given here is 58 kg. So the alternative hypothesis is it is not equal to 58 kg. Until and unless we find any such evidence, we will take the null hypothesis as true. So we will develop the null hypothesis. We will develop against that, there will be an alternative hypothesis. We will carry out necessary step and we will see whether the null hypothesis holds good or not. If it doesn't, if it holds good, well and good. If it doesn't, then we will say that the null hypothesis is rejected and we accept the alternative hypothesis. What is the procedure? First is setting up of the hypothesis that we have already talked about. Next is to set up a suitable significance level. Now, what is a significance level? Say when we are testing something, we will select a level to determine whether we will accept something or reject. In general, we say the significance level that is selected is 5% or 1%. In some cases, 10% is also selected. So what does this mean? Significance level, what does this mean? See, if we say that 5% is the significance level, that means that Out of 100, the chances that 5% case we will reject the null hypothesis. So if we denote it with significance level, we will say out of 100, there is 5% chance that the null hypothesis will be rejected. If it is 1% significance level, then out of 100, there is one chance that the null hypothesis will be rejected. Alternatively, we can put it this way that out of 100, there is 95% chance that the null hypothesis will be accepted. In that case, we will call this as 95% confidence level or 5% level of significance, whichever way you want to put it. If you want to say from the rejection angle, it is 5% level of significance. If you want to take it from the acceptance angle, then that is the confidence level. So whatever it is, whether 5% or 1%, the level of significance that needs to be chosen. So first we will set up the hypothesis, then we will set up or then we will choose the significance level, the based on which we will test our hypothesis. Now that is denoted by alpha. Now this is how the graph will look. Uh, if say we are taking as 95% confidence level that out of 100 times 95% our null hypothesis will be correct, then it will fall in this white region. And if we say that 5% times we will reject the null hypothesis, then it will fall in the shaded region. So later on we will see if our computation falls in the shaded region, we will reject the null hypothesis. For the time being, we are ignoring the graph. So basically we have set up the hypothesis, then we will decide upon the level of the significance. Now, third stage is to determine the suitable test statistics. So depending on the type of data available to us, we will decide whether we will do t-test, whether we will do z-test, whether we will do chi-square test, and so on. And we will calculate the test statistic. Then we will determine the critical value from the table. So there is a z table, there is a t table, from where we will determine the critical value. Next, we will compare the value which we have calculated with the value which is shown in the table. If our calculated value is more than the table value, then we will reject the null hypothesis and vice versa. I repeat once again, hypothesis setup, significance level decided, depending on the data we will or the type of test we are depending on the type of requirement and the available data, we will have to select the suitable test. Then there will be a critical value from the table. That calculation we will see later on. If it is a z test, from the z table, if it is t test, from the t table we will get the value. Then we will compute and calculate the test statistic, what is will be our computed value. That computed value needs to be compared with the table value, and if the computed value is more than the tabulated value, then we will reject the null hypothesis. So if the computed value is more than the table value, then it will fall in this shaded region and the null hypothesis will be rejected. So this is at a glance what is needs to be done. Formulation of the hypothesis, selection of the appropriate test, choosing the level of significance. If I go with the right hand side of here, we will calculate the test statistic, we will compare it with the tabulated value, and depending on whether the test statistics computed is more than the tabulated value, we will reject the null hypothesis or we will accept the null hypothesis, and we will do the necessary we will draw the necessary conclusion. Another way of determining whether to accept the null hypothesis or not is through the probability. So we will get the probability associated with the test, and we will compare it with the level of significance. Say for example, we are we are testing it at 5% level of significance, 0.05. So if our probability is less than 0.05, we will reject the null hypothesis, or else we will accept the null hypothesis and we will draw necessary conclusion. Whichever method you follow, you will get the same result. Uh, for here in our example, we will at least one or two examples, we will use both the method, but generally we will take up the probability. You will use the probability, that is easier, and we will draw necessary conclusion. This is what is done in testing of hypothesis in brief. Uh,
Excuse me, sir.
yes.
I have a question. Mostly that we are doing academic research, professor are assigning some tests on our research paper. In most of the cases, I don't know, in almost cases, we reject the null hypothesis and accepting the alternative hypothesis. Is this a predefined, or in some cases we can also accept the null hypothesis and reject the alternative hypothesis, and we can go on with our research model with the null hypothesis?
I get your question. Uh, Officially, I won't answer it now. After the end of the lecture, I will answer this. If you can,
Okay. Okay. Thank you, sir.
I will come to this question. Now, while testing the hypothesis, there can be four different situations. Say, I say the average weight of this class is 60 kg, and actually it is 60 kg. I say the average weight of this class is 60 kg, but actually it is not 60 kg. So there can be a situation when I say the average weight of this class is 60 kg, it is actually 60 kg. My test is supporting my hypothesis. The another case is that I am telling that the average weight of this class is 60 kg. In reality, it is not 60 kg. The average is not 60 kg. The test is rejecting my null hypothesis. That is also correct. But there can be a situation when I say the average is 60 kg, in reality it is 60 kg, but after doing the test rejects the null hypothesis. And another case is that I say null hypothesis is 60 kg, in reality it is not 60 kg, but the test result accepts it, that no, it is 60 kg. So in two cases, we can get an error from the testing. So those two errors are known as type 1 and type 2 errors. So when we reject a null hypothesis, when it is true, actually it is true, the null hypothesis in reality is true, but through our test we have rejected it. That is known as a type 1 error. And another case is the null hypothesis which we have developed, actually it is false, but we have conducted the test and the test result accepts this. So that is known as the type 2 error. These are the two situations which are the two errors which we can come across. So we can show it with an example. This is a very common example people use, that in a court trial, the defendant is, until and unless proven guilty, is taken as innocent. So that is the null hypothesis. Now these can be the situation, four different situation. Our null hypothesis is he is not guilty. Actually, he is not guilty. The null hypothesis is accepted. That is the right decision. Another case is the extreme right towards the end, that our null hypothesis is he is not guilty. but actually the defendant is guilty and the test result rejects our null hypothesis. So these two are correct. But take the case where uh, the null hypothesis, he is not guilty. Actually, the defendant is not guilty, but the test result rejects the null hypothesis and accepts the alternative hypothesis that he is guilty. So that is a type 1 error, rejecting something which is correct. And the other is uh, he is the null hypothesis, he is not guilty, but in reality he is guilty, he has committed some crime, he is guilty, but the test result uh, says that no, he is not guilty. So these are the two types of errors, type 1 error and type 2 error, that can be that we can come across. One is due to this error generally comes due to selection of the level of significance. Too stringent or too lenient level of significance. Say if we take 1%, that is too stringent. If we take 10%, it becomes lenient. So one, when taking up, when constructing the, while doing the test, has to keep these things in mind. But however you try, you there will always be the scope of some error. The one-sided, one tilde, sorry, uh, type 1 and type 2 error you might come across. Next is one tail test and two tail test. These are the terms which we are taking, which later on in our example we will come across. Now, what is one tailed and two tailed? You see, this is the normal curve. Now, both the rejection area, one is on the right hand side, one is on the left hand side. So if for a two-tailed test, the rejection level can be on any of this area. And for a one-tailed test, it can be on the right side or it can be on the left side. That is known as right-tailed test or left-tailed test. Say we say that the average weight of this class is 60 kg. Alternative hypothesis is the average weight of this class is not 60 kg. It may be 65 also. In that case also our null hypothesis will be rejected. The it might be 55 also. In that case also the null hypothesis will be rejected. So it can fall on either side. But if I say the average weight of this class is up to 60 kg, so 60 or less is accepted, but more than 60 kg, we will, if it is more than 60 kg, we will reject the null hypothesis. Then it falls on one side of the tail. If it is on the greater side, then it is on the right hand side. And if it is on the left hand side, say we say that the average height, the minimum height of this class, minimum height of the student of this class is 5 feet. So 5 feet or more is acceptable, but if it is less than 5 feet, then the null hypothesis will be rejected. In that case, it will fall on the left hand side. So if we conduct any test where the critical region is both on the right side as well as on the left side, it is a two-tailed test. And if it is on one side of the curve, then it is a one-tailed test. Actually, this middle one is the two-tailed test. This one is the one-tailed test, right tail, and this is the left tail. Uh, Technically, it is called this is called directional test, but all these technicalities we are not going into it. Next, we come to the testing of the hypothesis. Now, the hypothesis testing may be parametric or non-parametric. Now, parametric test, we will do this when the theoretical distribution follows the assumption that the distribution of the sample data is normal. In that case, we will do parametric test. Uh, and non-parametric tests are distribution free. We do not assume that the data which we are using will follow any particular distribution. So when we assume that the distribution follows a pattern, generally that is normality, then we apply the parametric test, or else we will apply the non-parametric test. Here we will gain mostly, we will deal with the parametric test. The parametric test may be a Z test or a T test. Sorry, it may be a T test or a Z test. It may be a paired t-test, and there can be ANOVA. Say, if there is one sample, a single sample, we will take each and every one in detail. If we take one sample, there can be t-test or z-test. If we have two samples, then it can be a t-test, it can be a group t-test, or if it is a paired sample, then it will be a paired t-test. If it is more than two samples, then we will do an ANOVA. We will take all these and we will see how testing is done in SPSS. Now, when we say t-test, t-test means the distribution will be similar to a standard normal distribution. Now, one term that we will come across when we will do the t-test, that is known as the degree of freedom. So degree of freedom, basically it is, we will just have this idea. This is the basically the independent piece of information that we can use to calculate the statistics. So the number of free information, independent information that will be available to us to calculate the statistic is the degree of freedom. Why we are in talking about degree of freedom? When we will check the table, T table, Z table, we will see the table is related with the degree of freedom. So that's why we are talking about this term. Now, t-test, just we have shown earlier, one t-test, we go this way, one sample, two group t-test, and paired t-test. So one, two, three types of t-test. Z-test, one sample. Z-test, independent samples, two samples. And if more than two samples, we will go with the ANOVA. So basically, we will see here three types of t-test, two types of Z-test, and ANOVA. When we compare only one group of values, say we have taken our data from one group of value, then it is a one sample test. If I take the weight of all the students, sorry, if I take the weights of some of the students of a class, then it is a one sample test. Two sample unpaired group is that, say, company A, company B, two pizza delivery company, they are delivering pizza. So the average time taken by both the companies are the same or not. If we want to compare, then it will be a two sample t-test. And paired t-test is applied, say, when there is a pairing. Say, before taking tuition, this is my result. After taking tuition, this is my result. Will that tuition have an effect on my result? So that type of comparison is a paired. Uh, in that type of comparison, we will use a paired t-test. So paired t-test will be used of the same individual studied at two different times or under two different conditions. Now, what is the key difference between t-test and z-test? We have talked about t-test, we have talked about z-test. There are many reasons to use a t-test and a z-test. Simply speaking, a z-test test will be used when the sample size is large. Large means we take the n as the sample size greater than 30, and the t-test will be applied for a small sample which is less than 30. So we will apply the t-test for a small sample, and we will apply the z-test for the large sample. Now these t-test and z-test, they are all parametric tests which requires the condition to fulfill the condition of normality. We will take up first one sample t-test. This is a data that is given. The claim is that the average blood pressure is should not be more than 129. Here, so a sample of 12 men were taken and their blood pressure was recorded. We will see two things from here, that at 95% confidence interval, what should be the range of the blood pressure? Minimum, what can be the blood pressure? Maximum, what can be the blood pressure? The range within which the reading will fluctuate. And then at 99% confidence interval, that is at 1% level of significance, we will see whether this claim is correct or not, that the average blood pressure of a normal male should not be more than 129. That is what we will see. Before that, we will check the normality of this data. Now, generally, for the remaining example, for one, we will see the testing, we will test the normality. Generally, we will assume that the distribution is follows more or less a normal. Now, how can you determine the normality, or how can you check the normality? So basically, one can be the visual method through the histogram, or you can do formal statistical test. You can use the Sapiro-Wilk test or the Kolmogorov-Smirnov test. So there are people who use both the test, but generally for the smaller sample size, the Wilk test is used and the Smirnov test is used for a larger sample size. So let us take the data which is given here. This is the example given. What I have done is I have plotted the data in SPSS. So this is the blood pressure of 12 people given. So first, whether we will check whether it is normal or not. How to do it? We will select analyze, then go to descriptive statistics, and we will explore. The only information available here is the blood pressure. We select it and we transfer it to the dependent list. Once done, let us click plot, box plot, etc. not required. We select none. If I want to visually check the histogram, it depends. Then I will check the histogram. If I don't want, if I just want to do the statistical test, I will uncheck the histogram. So I am checking the histogram and I am checking the normality plot. Continue. Okay. You see here, this is the histogram. More or less, the distribution is skewed at a glance. If you see, it is a skewed distribution which can be taken as normal, but better to check through the statistical test. So these are the result, the Wilk test and the Simron test. In both this, at if we take the level of significance at 5%, 0.05, we find our p-value is more than, that is the probability is more than 0.05. As we have talked about earlier, that if the p-value is less than the level of significance, the null hypothesis will be rejected. In this test, the null hypothesis is H0 is that the data is normal, and H1 alternative hypothesis is the data is not normal. So we will assume our hypothesis is the data is normal. And since the p-value is more than 0.05, I have say I am testing it at 5% level, it is more than 0.05, the null hypothesis is rejected. Sorry, the null hypothesis is accepted, and we say that the data is normal. So this is how we will test the normality of the data. So once we have checked the normality of the data, we can now proceed with the t-test. The example says, the example requires us to compute at 95% confidence interval the mean systolic blood pressure for the adult. So we will see the range, we will calculate the interval. The same data, we will take analyze, then we will go to compare means and one sample test. We will click one sample test. The data is blood pressure, which is, we will transfer it as to the text variable. While for calculating the range, we will keep the value as 0. In this option, the question here says at 95% confidence level. That means our level of significance is 0.05, which by default here selected is 95%. So if you want to test it at level of significance at 0.01, then you can change it to 99 if required. So in this case, it is given, the question says 95%. So okay, once it is done, select OK. Now, how we will find the level? In this one sample test here, at the 95% confidence interval, you will see there is a lower bound, there is an upper bound. So from this, what can we say? This is, we have done it at 95% confidence level. So we can say that we are 95% confident that the blood pressure of the adult male will vary between 124 to 142. So this is the range selection. If you are asked to find the variance with the range in which the it will vary, so this is how we will find out. Let's go to the second requirement. Second requirement is actually the, we will see whether the hypothesis that we have developed, whether that is correct or not at 1% level of significance. So the average blood pressure is 129. So what will be our hypothesis? Hypothesis will be H0. This is the average denoted by mu. H0 is should not be more than 129. So against this, the alternative hypothesis is mu. If it is more than 129, then the null hypothesis will be rejected. And the level of significance is 1%. This is the testing that we will do. So let us go back to SPSS. The same data we have. So here, analyze, compare mean, one sample test. Since I have done the same test before, that blood pressure is already selected, you will find it this way. You will take blood pressure as the test variable. While calculating the range, we have taken the test value as 0. But now our null hypothesis is 129. So our test value will be 129. And in under option, we will level of significance is 1%. So the confidence interval that we will write here is 99. So we are testing it at 1% level of significance. Then OK. So this is the result we are having. So we will check both the way of comparing, once through probability, another through the p-value. So here you see the t-value given is 0.994. So let me note down, t-value is 0.994. Now, what kind of test is this one? This is a one-tailed test. The blood pressure of less than 1 up to 129 is acceptable. If it is more than 129, then it is not acceptable. So it is a one-tailed test. Here, the degree of freedom is 11. Degree of freedom is n minus 1. Here, the number of observations is 12. So the degree of freedom will be a 12 minus 1, that is 11. So how we will, this is the t, it is the calculated value. Next, we will check it with the tabulated value. So this is the t table. Now, what will be the tabulated value? Degree of freedom is 11%. Level of significance is 0.01. And so one tail test 0.01. This is 0.01 under one tail test. One tail 0.01. We go down. Degree of freedom is 11. That is 2.718. So 2.72. So the t value that we have obtained is 0.994, and the table value, the value from the table is 2.72. So in our initial, when we have started this session, we have said, while doing the testing of hypothesis, we have said, if the computed value is more than the tabulated value, the null hypothesis will be rejected. But here, the computed value, the t value, it is less than the tabulated value. 0.994 is less than 2.72. So we cannot reject the null hypothesis. So null hypothesis is accepted. This can be one way of deciding. Another way of deciding is through the probability. Here, probability, our level, we are testing it at 1% level of significance, 0.01. If we Go to the table. Here we will find the p-value that is given is 0.324, 0.342, but that is for a two-tailed. Now here we have done a one-tailed test, so 0.342 we will divide it by 2, one tail, that will be 0.171 0.171 and 5. So p-value is 0.175 while the level of significance is 0.01. In this case here, the tabulated value should be more than the computed value should be more than the tabulated value to reject the null hypothesis. And in this case, it is reverse. The p-value should be less than the alpha, so to reject the null hypothesis. But we find here that the p-value here is more than 0.01. So null hypothesis is accepted. So whichever way you like, you can do the testing, but this is the easier way comparison that can be done. So this is the first test, that is t-test, one sample t-test. Are you all with me? Am I being able to communicate to you?
Yes, sir.
Sir.
Okay.
Yes, sir.
Yes. Yeah.
Yes, sir.
Okay. Next is two sample t-test. This was a one sample t-test. Next is a two sample t-test. Now here the pollution index of two area are given, and the claim is that the average pollution index of both the area is same. So we need to check whether this claim is correct or not. So how we shall develop the hypothesis here? Here 80 is the average pollution index of area A will be equal to the average pollution index of area B. Some people write it this way: 80 mu A minus mu B is equal to 0. Against this, the alternative hypothesis is the average pollution index of both the area is not same. Or if I write it in this style, then this will be mu A minus mu B not equal to 0. The level of significance is 0.05. This is what is given. Let us go back to SPSS. I have all the data fitted saved with me. You see here area A, the pollution index is given for 1, 2, 3, 4, 5, 6, 8 days, and area B given for 8 days. Now the data is plotted here. This is for area A and this is for area B. Now, SPSS requires the data to be coded. It won't understand A or B. So we have to give some coding. So coding maybe area A will be 1 and area B will be 2. Say, for example, how coding is done. If you go to the variable view, under, I am taking a new one, say XYZ, whatever be the name, I have given a name, decimal place 0. Under value, I will choose, say 1 is given to area A, add 2 is given to area B, add. Okay. Go back to the data view. Under XYZ, if I write 1, automatically it will take as area A. If I write 2, it will take as area B. So this is how it works. So this is already, the leveling is already done here. So this is, I don't require this, just for showing. Let me clear this. So area A, area B, these are the pollution index. For coding purpose, area A is denoted as 1, area B is denoted as 2. I have written the null hypothesis, I have written the alternative hypothesis and the testing. We will do it at 95% confidence level, that is 5% level of significance. So, analyze, compare mean, independent sample t-test. We will click the independent sample test. We have here the pollution index, that is the test statistic figures, and the area. So the test variable index, we will take it under test variable, and the area, we will take it under the looping variable. Here we have two question marks given. You click as define group. Group 1, that is area A, we have denoted with 1, and group 2 we have denoted, that is area B, we have denoted with 2. Continue. Check the options. It by default 95% level. We are testing it at 95% level only, so we need not change anything. Continue. Once it is done, okay. So this is the result we have. So our alpha here is 0.05. Let us check the p-value. Here you see, for a two-tailed test, this is the two-tailed test. It is 1.61, 0.1.62. So p-value is 1.62 and alpha is 0.05. So in order to reject the null hypothesis, the p-value should be less than 0.05, but actually it is not so. So p-value is greater than 0.05. So null hypothesis accept. So this is the easier way out. But other way, what is the tabulated value? Tabulated t-value. It is two-tailed test 0.05. The degree of freedom here is 14. So T-tail test 2-tail test 0.05, degree of freedom is 14. That comes to 2-tail test 0.05. It is 2.14, sorry, 2.145. And the t value which it is computed is 1.478. So the computed value is less than the tabulated value. So null hypothesis will be accepted. So henceforth for all t-test, we will not check the table. We will just compare the probability. That was for a one-tailed test. This was for a two-tailed test. This is how we will read the table. For one tailed, if it is at say 5%, 0.05, we will follow one tail 0.05. That column is chosen. You go down to that column, whatever the degree, say if it is 10, then 1.82. For a two-tailed, if it is 0.05, this is 0.05, we go down this column. If the degree of freedom is 13, come to 2.16. So this is how we will read the table. This is the tabulated value. Against that, we will compare the computed value. If the computed value is more than the tabulated value, then we will accept the null hypothesis, or else if the tabulated value is more than the sorry, if the computed value is more than the tabulated value, we will reject the null hypothesis, or else we will accept it. So in this case, we have accepted it.
Sir,
So,
in table explain F and significance F 0.65, F
uh,
and SIG. Explain these two things.
this is not part of for the t-test. There will be many things reported. For
Uh,
us, only that which is concerned, we will take that
T-test.
t-test. Here we are doing t-test. You see here the t value
Uh,
1.478. We have taken that. We have taken the t significance 1.92. There will be lots of information available. We will just take up those things that is required for this testing.
okay, thank you, sir.
Okay. Next is paired t-test. Just a moment. Next is paired t-test. Paired t-test, we will take two different examples and we will see how this is done. Now, this example is given for one particular day. This is the reading of the air sample in two different areas. It will be read this way. Day 1, 2.92 in area A, 1.84 in area B. Day 2, this row. Day 3, this row. So there is a pairing with a particular day. These are the readings in two different areas. Now we will see whether there is a significant difference in the mean of the what is the asked here, air sample, the pollution of the air sample that we will see here. So let us first frame the hypothesis. So hypothesis here, H0 is the mean. There is no mean difference, mu d. Mu is the mean. There is no mean difference between the air population pollution sample of both the area. These are paired on one particular day. Area 1, area 2 data available. Next day 2, area 1, area 2 data available. Against this, the alternative hypothesis will be there is significant difference in the average of the air sample. Our level of significance is 5%. This is given. This is the example, area A, area B. It is given. This is it is plotted here, area A. On day 1, this is the reading of A and B, day 2, A and B, and so on. So how we shall proceed here? We will take up analyze, compare mean. We move to the paired t-test. Area A and area B, both of them should be selected together. I'm selecting both of them together and I'm transferring it as the paired variable. You can go to the option and choose the level of significance. So here the confidence interval is 95% and we are testing it at 5% level of significance. So nothing to change. Continue and select OK. This is the result available. Now let us here we won't now again we won't go to the table, just we will take the probability here. You see here the p-value 0.002, 0.00. So basically the value is 0.00002. So our p-value is 0.1234. I may miss out a zero also, it is very small, whatever it is. So this is the p-value and this is the alpha. Alpha here is 0.05. So the p-value is less than 0.05. So we are rejecting the null hypothesis and accepting the alternative hypothesis. So we are rejecting H0 and we are accepting the alternative hypothesis, and we can comment that there exists enough evidence to conclude that there is difference in the pollution index of the two areas. So the earlier two examples which we have taken, there the or null hypothesis was accepted. So in this case, the null hypothesis is rejected. Let me take another example from here. These are the students. They have taken a lesson in a particular module. Before taking up the lesson, these were the marks, and after taking up the lesson, this is the marks. So, is there any significant difference uh, as a in the marks as a result of studying that module? The purpose of this example here is, in my last example here, we have we have tested it through this analyze, compare, mean, and we have taken a paired t-test. The same test we will here use, we will we will calculate it in something in a different way. So what is to be done here? What we will do here is, we will first, actually, if you remember when we were writing the hypothesis, mu d is the difference between the pair. So here we will use transform compute variable. These are the two variables given. So a new variable will be created. It can be difference. I'm just writing the short form diff. So the difference is between this one minus this one. So old minus new or new minus old, whichever way you take, you will get the same result. Okay. Now we have a new variable created, difference. This is the thing created. Now what we will do, using this difference, we will go to analyze. We will just do a one sample test. Compare mean, one sample test. We will take the difference. The level of significance is 5%. Okay. So this value is 0.04. So which is less than 0.05. So we are rejecting the alternate null hypothesis, and we accept the alternative hypothesis that the effect as a result of studying the module, there is a significant change in the marks of the students. So this is the different way of calculating. In the first one, the same test, I am using the paired t-test formula, and in the second example, I am coming to the same conclusion. Instead of using the paired t-test, I am doing calculating the difference, and I am applying the one sample test. Even if you do the paired t-test here, you see, if I do the paired t-test here also, the level of the probability value is 0.04, the null hypothesis will be rejected. The same test we have done through a different way. We have calculated the difference and done a one sample test. So this paired test, t-test, can be done, we can get the same result through a one sample test also by calculating the difference. So this is all we have from the t-test. One sample t-test, two sample t-test, and the paired t-test. Two sample t-test is both the samples are independent. And in case of paired, there is a pairing either before, after, or relating to a particular date, this. So this is how the t-test is carried on when the sample size is less than 30. Next, we shall move to the Z test. Now, t-test generally we were dealing with the mean. Z test is proportion. In relation to this, we we will find out something. So one proportion Z test. This is an example. A certain soft drink bottler claims that less than 20% of its customer drink another brand of soft drink on a regular basis. So he says that uh, so more than 80% of the customer drinks his brand, less than 20% drinks other brand. And the sample was drawn out of 100, 18. The sample shows that 18 of them is drinking another brand. So apparently the claim seems correct. Now we will see at 5% level of significance whether this claim is correct or not. Now the problem with Z test is that SPSS doesn't have the provision to conduct Z test. There is no command there, but we will use a other way around way. We will go other way around and we will see that how to use SPSS in conducting the Z test. So let us develop the hypothesis. This is the null hypothesis that less than 20% of these people drinks other brand product. So proportion is 20%. So if more people drink his brand, so there is no problem. So H1 will be the alternative hypothesis. It is less than 0.2 and level of significance is 0.05. Now, these two things, these are the data. Out of 100, 18 drink other brand product. So the remaining 82 will drink the same brand product. Now, you have to code this. The other brand product is already done. Just we have that I have shown in the other example. The first one, we will code it as 1. The second one, we will code it as 2. Alphabets, SPSS will not recognize. So after this, what we will do, we will apply the chi-square test. Why we shall apply the chi-square test? There is a relationship between chi-square and z test. The relationship is that the z value is root over the chi-square value. So SPSS does not support z test, but in SPSS we can do chi-square test. We will do the we will get the chi-square value, and we will from there we will get the z value. So how the chi-square test is done in SPSS? First, you take the data and then you weight the variable. Weight by case. This is the count, other and same. You transfer the count here, click OK. Next, analyze. After analyze, we will go to the non-parametric test. Non-parametric chi-square. You select the chi-square. Now the test variable is brand. You transfer the brand here. What is the count? Our one is other brand, the two is the same brand. So the hypothesis is 20% of the people other brand and the remaining 80% of the same brand you add. So once it is done, you run the test. You will find here, this is the chi-square value 0.250. So so it will be 5 into 5, 0.5 will be the Z value here. Our alpha is 0.05. Let us calculate the p value here. What is the p value here? It is so basically this is a one-tailed test. So you divide the p value by 2. 0.617 by 2. 0.309 approximately, while the alpha is 0.05. So the p value is more than 0.05. So we cannot reject the null hypothesis and we accept the null hypothesis. And we comment that there is no such evidence or not enough evidence to conclude that less than 20% of the customers drink another brand. This is with the help of your probability. Alternatively, we have the Z value. We have calculated the Z value as 0.5. From the Z table, we will get the table value. This is a one-tailed test at 5% level of significance. So one tail test at 5% level of significance, the tabulated value is 1.645. So if the computed value is more than the tabulated value, so the computed Z is zero point 0.5 and the tabulated value is 1.65. So the computed value is less than 1.645. So the null hypothesis needs to be accepted. So even though we don't have Z-test option here, we are using the other way around. We are using the chi-square test. Since chi-square has a relationship with Z-test, we can use it to calculate the, we can use it to draw necessary conclusion. This is a one proportion Z-test. Next is two proportion Z-test. We have done the t-test one sample, two sample t-test, and paired t-test. This is one proportion z-test we have done. Now we are doing the two sample or the two proportion z-test. This is a test of reliability of the product by two machines. So in machine A, 15 defective parts out of 280 produced, 15 are defective. And in B, out of 200, 10 are defective. Now the question is, are both the machines equally dependable or equally reliable? So this is what we will see here. We will test it at 1% level of significance. So the null hypothesis is 80 proportion A is equal to proportion B. There is no difference. An alternative hypothesis, there is difference in the reliability or the production of the machine. So this is the null hypothesis, an alternative hypothesis. We are testing it at 1% level of, just let me check the problem, at 1% level of significance. Now you see, this is the machine A, defective and acceptable. The out of 280, 15 were defective. So out of 280, 15 were defective. The rest 265 is acceptable. And machine B, out of 200, 10 are defective. So 10 defective, the rest 190 is acceptable. Now both the first machine, machine A, we have coded it as 1. Machine B, we have coded it as 2. The defective, we have coded it as 1, the one we have, for which we are doing the testing. And the acceptable, we have coded it as 2. So this coding is already done. Next, we will run the, we will check the chi, we will find the chi-square value, and from that we will calculate the z value. So first, data, then weight case by the frequency, that is the count. Okay. Next, we run the command analyze descriptive statistics cross tabs. The first one, machine, will be taken to the row. Next, the quality will be taken to the column. We will click the statistics. Statistics is chi-square, and statistics we have written chi-square and OK. So we have many things reported here. We will just check only the chi-square portion. Now, in this chi-square portion, the p-value is 0.862. 0.862, and our level of testing is the level of testing is 0.01. So 0.862 is more than 0.01. So we cannot reject the null hypothesis. We have to accept it. That is through the probability. But since here we are using the roundabout way, the chi-square, to find the z value, let us calculate the z value here. So z value, the chi-square value is 0.03. So z is root over chi-square 0.03. So square root of 0.03, it will come to 173. This is the z value, and the tabulated z value is we are testing at alpha 0.01, and this is a two-tailed test, so it is coming to 2.58. So z value from the z table is 2.58. So here the z value, the computed z value, is less than 2.58. So we accept the null hypothesis. And so we can conclude that there is no evidence that the reliability of both the machines are different. So this is how we will deal with the Z test. Next, we come to, up till now we were doing with either one sample or two samples, whether paired or unpaired. Next, we will take more than two samples. Here, we will take a three sample. If you can kindly excuse me just for 2 minutes, I will just join after 2 minutes. Just Mr. Daya, hello.
Yes, sir. Yes, sir.
আমার just
Okay, sir.
1 minute
Okay,
একটু
sir. Okay, sir. No problem.
Sorry for the delay. Okay, so next we were talking about ANOVA.
7 बजे.
So when we are having more than 3 or more variables, we use the ANOVA. Let me take one example. This is a very common example which is used, that 3 sets of 5 mice were randomly selected to be placed in a standard maze with different colors. Actually, basically what happens, that this maze, that is the zigzag path, there are 3 colored doors, red, green and black. The mice, 5 mice were taken and they were put once on the red, green and black, and the time taken to run, or the time taken to complete that maze, that was recorded. Now the question was that, has the color of the door any impact on the time? The response time is recorded to complete the maze, and perform the appropriate analysis to test that if there is any effect due to the door color. So whether the color of the door is having any impact on the time. So 5 different 5 different mice, they ran on 3 different colored doors. Their time was recorded. Now the question is whether the color of the door has any impact on the run time. So we will first develop the hypothesis. Null hypothesis is there is no significant difference in the average runtime depending on the color of the door. So mu red is equal to mu, the second color is green, and the third color is black. So there is no difference. An alternative hypothesis is at least one inequality. All of them may be different, at least one may be different. So here we have more than two samples, so at least one inequality. This is the alternative hypothesis. And the level of significance that we are testing is 0.01. Alpha is 0.01. Now, these are already been recorded here, red, green, and black with that time. So red denoted with 1, green denoted with 2, coded with 2, and black coded with 3. This is already done. So how we shall proceed? Let us select analyze, compare mean, and go to one-way ANOVA. Now you select the time and take it as dependent, and you select the color and take it as factor. The effect of color on time. So time dependent, the color as the factor. Next, you click on post hoc. In this post hoc, you select the true key. Our level of significance is 1%. By default, it is given here 5%. You change it to 1%, 0.01. Click continuity. Then click on the options and select homogeneity of the variance test. Click continue. Once done, run OK. Now, what will be our conclusions here? Our conclusions here for the F test statistic, this is 0.000151, which is less than 0.01. So we will reject the null hypothesis that there is no significant difference in the color and accept that at least one of the color is having a significant effect on time. Now, which color is having a significant effect on time? Here, if you go to the homogeneous subset, you will find here red and black is grouped under one head and green is grouped under another head. So green is having a significant impact on the uh, time. Also, you can check it from here under green, it is less than 0.01, and but the others are not significant, only green is significant. So from either of this you can say that first is this is significant, means if there is, we are rejecting the null hypothesis and we are saying that at least one is different. Now which one is different, that you can say from the post hoc test, or you can say from the homogeneous subset, you can comment which one is different.
Sir, once again, post hoc, explain once again.
In this post hoc, you see here, if I take here red, green, black. Green here is significance is 0.01, and in black also only green is significant. So either you can comment, check it from this way, or you take green and you will find that it is having significant effect 0.01 or 0.00. This is one which taking with others you take green, that will be significant, and with green you check the others, you will find. So only where green is there, significance is there, others are not significant. Or you go down here, you will find the one which is different, it is grouped, otherwise the rest two which are not having significant difference are grouped together. So from this you can say which one is having an effect here. So this is all we have for parametric test now, and my discussion ends here. But there was a question at the beginning, I would like to answer that now. Please, if you can ask the question once more.
Sir, the question regarding hypothesis.
Yeah.
Yeah, sir. In academic career, we said that we reject the null hypothesis and accept the alternative hypothesis. Is this a predefined one that always we reject the null hypothesis and accept the alternative hypothesis,
uh,
or in some case we can accept the null hypothesis and go on with the null hypothesis?
uh, Actually, what is your research background? Which stream you are doing your research?
Yeah, sir, by profession, I have done my economics degree, but unfortunately, I didn't find any job in related field.
No, no, no. I'm
It's
not. No, I'm just asking your research area. Which is the research area?
sir, in the trade area.
Actually,
Trade.
I can answer this from my point of view. I am actually from the commerce background. There, the main objective of the students or the researcher, some way or the other, is to find something which is significant. So for that, they always would like to get something if they like to reject the null hypothesis. But this is the mindset of the researcher. But actually, that shouldn't be the case. But I have seen people in advance decide what test to use, and irrespective of the nature of data, they try to fit in that test. So these are predetermined things where researchers do, but that shouldn't be done. If the null hypothesis is being accepted, then it is accepted. You have to accept it. Always, it's not that every research will give your desired result.
Okay, sir. Thank you so much for the clarification.
Anything else? Hmm. Okay, that's all from my end. I think Mr. Dashankar is not here. So thank you.
Okay, sir. Thank you. Thank you.
No, sir, I am here.
আপনাকে আমি দেখতে পাইনি, তাই ভাবলাম আপনি নেই বলে। ঠিক
না, আমি অরূপ অ্যাকাউন্টে আছি।
আচ্ছা আচ্ছা, ঠিক আছে।
Thank
আপনার
you, sir.
finish
Very
হয়ে গেছে?
nice lecture, sir.
থ্যাংক ইউ, থ্যাংক ইউ।